So. All right. So that's where we ended up. With a bit of light. I don't know. What do you guys think? Up to you. So it's probably legible because largely black and white. There's a bit of code there, but the code doesn't matter too much. So that's more exemplary. Because the other one, the rest is relatively straightforward. I think normal service implementations. Or is there any magic, Marish, you think is worthwhile mentioning? No, right? So it's just a code container for your purpose, and you can basically configure as to how you want to run it semantically. But probably what's more interesting, because you will probably not touch it immediately anyway, and thus, at least interesting to know about, is the bound service, or bounded service. I think it's the correct syntax. I shall never understand that. Anyway, so it's the kind of the last category of the different services we saw, right? We had foreground service, we had the intent service, the service, and the bounded service. And the idea here is the bounded service is that it emulates quite well a client-server model of interaction using message passing. So again, it's a specialization of the general service, but very specific about the use case. So that the service itself acts as a server de facto, which expects invocations by clients. Yeah? Generally activities, but can be of a different nature as well. And think about it like from many of you do game development. Think about it like a practical application, of course, would be a kind of lobby mechanism for a multiplayer game where you have some chatting mechanism or things like going on, right? So you have a kind of a server and clients connecting to it. And for this kind of prototypical application, this may be just a suitable case, right? So having a bounded service as opposed to modeling everything yourself. Of course, you can do that yourself by implementing it and bearing in mind the multi-threadedness of the interaction and so on. But here you kind of get it out of the box as well. So I don't think it's heavily used in practice, but it can't hurt. Plus it gives us the opportunity to briefly talk about IPC as well. And I think that's always a sensible thing to learn about. So its use case is state synchronization. So lobby is a classic example, but probably also game information. There are some constraints there, but that would be a possible pathway. And you interact using a fixed interface, they call I-binder interface. That's the key idea. And the neat part it provides out of the box is communication across processes, IPC support. Who of you has been dealing with IPC or had needed to deal with IPC before? Please, yeah.
I used IPC before, and I had to do I had like one thread collecting things that had to be decrypted, and I had other working threads and processes decrypting them. So it's like pipes, channels.
All right. Okay.
And
right.
Also used just like shared memory.
Right, okay. Shared memory synchronization, basically.
Yeah, I had software that read memories.
Right. So interesting. Which programming language did you use?
C.
Right.
Mostly.
I wouldn't expect anything else. That would be the prototypical language for that kind of exercise, right? So that's definitely one of the pathways you can take it, right? So it's literally moving away from the individual applications and actually have cross-application. I'm not talking cross-process application as process in this case, communication, right? So on operating system level, and that's basically bring you down to the operating system. Use pipes, for example, which are in this case a component integral operating system component, right? So you need to know something about the underlying operating system to some extent. But Android has it actually as well. So I'm not sure how heavily it's used, but it's there as well for the purpose. So how does the bound or bounded service work? Well, generally you kind of need to deal with the this on bind method. If you implement the service, you will get that method anyway. Usually you return null and don't worry about it any further. But if you want to actually completely implement it, you will need to return an I-binder object, and it's basically a singleton that references the instance of the bound service or bind service, right? So you have direct interaction with the service, and you need to, of course, also provide. So just to emphasize the simplicity of this very approach, and a private handler that deals with incoming, asynchronously incoming messages as well, right? I'll show you some code examples as well, so it kind of makes more sense. From the client side, the activity side, for example, as an example of invocation, so client with a server, you would need to create some sort of service connection, which basically would be basically a callback mechanism to be informed about certain states, such as that the service is actually connected or disconnected and so on. And you bind to the service not by calling start service as with all the other service types, but here you actually call bind service explicitly. And it's basically an asynchronous call to the service connection, and then you get feedback, okay, hang on. So this call to bind service, it returns immediately, but you will actually eventually get an invocation on the callbacks to actually know, okay, now you're connected to the service. And then you interact using this iBinder object that you have been retrieving based on the onBind method that's provided by the server itself. Right, so a bit involved. So the bit more complex bound server lifecycle. So I showed you a simple one before, but the intuition is in fact the same. The idea is there that the service, if an individual, so if the service is actually running and clients are connecting to it, so if you're binding to a service and the service is not running yet, then it's going to be launched. And as long as individuals are basically bound to that service, or potentially unbind, but potentially also rebind to that service, the service continues to exist. Only when the last client basically leaves the service, or when it stops itself, of course it has the same execution autonomy as the service concept itself, so either it can be stopped internally or externally, then it will actually shut down. So that's the key idea. So as long as the service is running and clients are connected, it will continue to run, right? So that's the key idea of that service. So, okay, so just an example, sometimes code says more than words. So here we have the service. Yeah, so slightly annoying. So the service extends the usual service interface. Recall that you need to implement the onBind anyway, so it's just based off the conventional service class, sorry, not interface class. Then you need to create something like a local binder, which de facto is just a singleton that returns the local reference to the local service itself. So you kind of have a singleton implementation of this service. And on bind, you basically just return the reference to the location binder. And then you have some stuff happening here, right? In this case, there's some random number and so on. I borrowed this from another slide set in this example, so just to have something done that's potentially busy. But the key thing, if you actually bind to a service, you get a reference to the service, which is a singleton of the service class itself, the instant of the service class rather itself. From the client side, here's the activity that uses it, so the service is quite straightforward and simple. Here you notice on start, right? So usual layout of activity, on stop and so on. So on start, you're basically creating a new intent and actually bind the service, right? So you have an intent pointing at the particular service. So the action will point, the class specification will point to the service class, and you also have a instance of a connection, got to that in a second, and basically some parameters, you're binding the service, so if the service is not running yet, it will be starting at that state. The parameter you're passing along, in this case the M connection, is basically here, what I mentioned before, a local implementation of the service connection, which basically has two methods, one being on service connected, the other one being on service disconnected. So basically that's the callback that you need to await for before you can actually interact with the service itself, right? So that's the basic idea. And that's how it works. So you bind to a service, you get a notification. Once your service is connected, you get the reference to the service, which is passed along with the call to onConnected. And you get the service, yeah, then you can interact with the service instance, basically. That's the, yeah, for the whole magic there. Yeah, so that's the initiation. And the other aspect that is relevant, okay, how do we actually deal with messaging? Because if you send messages to a service, there's a specified message class, which is part of the Android API, and it's basically generally used for text messaging there. So that is, of course, a bit limiting in a certain sense, because you can't just inject your own kind of implementation of the message concept there. And it has certain concepts like topics and contents and so on. The message structure is a bit of a bit involved. And what you basically have there is that you have a message handler, or they call it messenger internally, that has an associated handler with this, that basically processes sequentially each incoming message, right? And you can, at this stage in the service, do something with this. For example, create a toast, right? Interact then with the UI in a wild sense and display something there. So yeah, so that's basically the essence, I think, about of how to deal or interact with the bound services you want to do that. So what you need, what's the benefit? Well, the benefit is synchronization is done for you. You have callbacks that indicate whether you're connected or disconnected from a service. You'll be notified if the service dies, and you can reconnect to it, and the reconnection is kind of automated. What is the pain? Well, you need to deal with all that overhead. There's a lot of boilerplate stuff you need to provide and buy into, be it the message structure, the service interfaces and so on. You lose a bit of flexibility there. So it really boils down to the use case that you actually have to warrant the use of a bound service. So something to explore. Independent of that, I think one of the aspects that's worthwhile talking about, because you may come across it when you look at the Android specifications and the documentation in a wider sense, is the reference to inter-process communication, which is precisely enabled by this bound service functionality because it's so rigid in its structure, right? So it has certain properties that are helpful in this. So as discussed here earlier, Victor made the point, inter-process communications basically relies on OS level interaction, right? Operating system level interaction between processes. Of course, ultimately in Android we fall back to the underlying Linux, but from a developer's perspective, that's not necessarily something we need to be terribly concerned about. The key thing about it, that inter-process communication is generally, well, is programming language agnostic, of course, because on the process level, just an injection, how many of you have heard the operating systems course? So not all, right? So, but most of it. The rest of you will hear it, right? Next year, is that correct?
We're having it right now.
Oh, you're having it right now. So did you talk about process control structures and
process control blocks,
PCBs? Okay,
yeah,
cool. That's precisely what it is about, right? So you have PCBs, you have pipes coming in and out and all that kind of stuff. This is the abstraction level on which the operating system interacts with your application, right? And IPC allows you to interact on that level because by generally processes are isolated, right? For a very good reason. Anyway, they're sandboxed, so they can actually be, independently killed by the operating system based on scheduling, memory heuristics, or whatever else. It doesn't really matter what the underlying decision making is, but you contain processes in this structured PCB, for example. And this is a way of breaking out of it and actually allowing two processes to communicate, right? So that's fundamentally the idea, but it's generic, therefore it doesn't necessarily rely on the programming language inside of those processes, of course, right? Because they can be fundamentally different, but it's also very expensive, right? Because it interferes with operating system level process scheduling, which is an expensive exercise. Because the idea is on operating system level, only one process should be scheduled at any time, whereas suddenly IPC would introduce some sort of interdependency between processes there. So in Android, there is, or in fact, in nearly all approaches to IPC, we have so-called interface definition languages. And in Android specifically, it's called AIDL, so Android Interface Definition Language, which is basically just a generic specification that allows you to, describe an interface. That's roughly what it is. I mean, there's no much magic about it. And this implementation is then used, basically, methods. Think about it like method name, return values, and parameters, and so on. So basically, a whole method signature that you conventionally use. And this then, of course, needs to be backed by programming language specific implementation of that corresponding interface, right? So on either side. So if you have two processes, one written in C++, one in Java, they need to conform to the same kind of interface as specified in the IDL, but of course they have their language-specific implementations based on so-called stubs, where a generator basically pre-generates the implementation in the corresponding language. You just need to fill the gaps and actually fill up the semantics. And then it fundamentally operates based on remote procedure calls. Basically, just sending a request to a invocation to a different process and expect a return value. But you don't really need to assume anything about the internals of that corresponding process, right? So RPCs as a way of interacting. As I mentioned, there's more than one IDL. In fact, there's a lot of them out there. So if you come across that term, interface definition languages, don't just think about the Android IDL, which is of course a relevant one here, but probably more interesting or more relevant ones, historically relevant ones, is of course the one from the object management group. So some of you may have heard about Corba. Oh, one has Corba. So that's one of the 1990s persons. So yeah. So the idea where there was, or the whole idea behind Corba was the common object request broker architecture, right? Am I correct? Good. So and the idea there was basically, okay, everyone thought, okay, we have so many different programming languages. Let's make our life simple and be indifferent about programming languages and allow different programs to talk to each other using a uniform interface and basically passing messages on this using this very mechanism that we're discussing here. And this I was basically summarized and formalized in the Corba specification, right? And then there were various implementations from the typical vendors, like IBM. Who else did something? I don't know. Borland had an implementation as well. So basically, that's where the industry came in, taking the specification to actually make it useful. Because in the 2000s, the challenge was we had a lot of fragmented operating information systems. We wanted to integrate them. And this was seen as a tool of doing that, precisely that. Okay, history lesson over, back to modern times. One thing that you probably come across in your lifetime as developers more realistically is protobufs by Google, which is really a cheap way of specifying a messaging format across not only processes, but also network and so on. So, but it's the same kind of approach. You basically abstractly define the layout of a message, including types and so on, right? So, that's the idea. For web services, we have the web service description language, which is probably still somewhat relevant to some extent. But there are various implementations out there, or various examples of IDLs out there. And the idea is, well, we take this interface definition source file, right, the abstract specification that works for all involved components, and using a compiler, you basically generate stubs in the corresponding programming language. Assuming this one is C++, this one is Java, it would create the stubs, basically the starting points for the actual implementation by the developer for the corresponding client application. So to ensure that when this one calls the client application or vice versa, that at least on an IPC level, meaning operating system level, the correct execution is guaranteed. Of course, that doesn't extend to the semantics internal to the application. That still needs to be coded by the corresponding developer, right? But at least the interfaces are well defined and line up and kind of work out. So that's the kind of general principle that underlies it there as well. So yeah, so fundamental idea is that we have the mapping from the internal interface to the external one, and it also deals with marshalling and unmarshalling of information, right? You guys know what that is? Marshalling, unmarshalling, a rough nodding, right? So it's basically if you need to get information on the wire or through your operating system for that matter, you need to kind of serialize it in a way so it can be reconstructed as an object, for example, on the receiving side, right? In this process, the serialization is called marshalling. Typical examples, what are typical examples of formats used for serialization nowadays?
JSON.
JSON, right? Classical one, human readable one, right? So we have BSON, right? So the binary JSON, which is more compressed in a way, but that's basically what it is, right? So you use JSON to reconstruct objects, and this is done now on OS level for you using that tool. That's the key idea. So in Android, how does it work? Well, you have some sort of AIDL file that is specified in the source, and it declares, of course, only method signatures, and the data types that are supported are those ones, so not much more than that. Usual primitive types, slightly more complex types here, or in fact, some collection specializations being the list, practically the array list and the hash map, and collections of permitted data types, basically. So it's all what's supported. So you kind of need to break down the message content or the payload to those primitive types, right? So if you have complex objects, you need to find a way of thinking, okay, how can I deconstruct them? So they're basically specified in the ARDL file and then built and generated into the corresponding Java file, implemented in the service, and then basically the stub implementation is provided and can be accessed via onBind. So whatever you turn is the access to the service functionality that's generated by the AIDL compiler. Yes, so yeah, that's it. And then you have a concept of parseable where you can actually specify how your object is going to be serialized, right? So you give some indication of which information is going to be serialized and which one not. Perhaps there's some runtime information that doesn't need to be going over the wire, because one of the things, again, IPC is costly, so you want to minimize payload. So that's an opportunity to do precisely that. I just, instead of me showing a made-up example, I just will briefly give you an insight into the IDL and just point you to the website. By the way, all the links that I'm using, the resources, are in the slide set, so you can retrace that on your own if you're interested to explore that later on. The Android example is fairly contrived, admittedly. So you'll find it under Developer Android Guide Components AIDL, sorry. And it basically describes the process. But what I want to do now is just to show you, briefly give you an intuition of how such interface files, the AIDL files, roughly look like. So it's really just like, it really looks like a Java interface. So slightly different. It doesn't have the specification of access modifiers, because the assumption is that they are all, of course, public here. So, for example, you have a get PID, you have some basic types, and you have a parameter, a set of parameters that are typed according to allowed types supported by the AIDL. AIDL, I will never get that right. And then your corresponding task is to, well, you know, take this generated stub. So after compilation, take that stub and actually do some sort of implementation. In this case, actually return the process ID. Well, in the contrived tutorial example for the other method, you see how it expands into proper Java. And for example, after compilation, it simply does nothing, but you could do something meaningful there, random number generating, or I don't know, concatenation of elements, you name it. So that's the key idea there, that this is done automated for you, and then can be consumable by other applications. So that's pretty much all I need to show you here in this context, or want to show you right now. But that's something that can be easily facilitated with bound services using AIDL, because you have this functionality of binding services in that way and ensuring that they actually bound to operating system level processes, so you can actually do interaction between different processes. I don't know how realistic that is for our usage. Do you plan to do anything on the operating system level in Android as your projects already? No? We haven't really talked about projects yet, right? Mariusz alluded to it. But if you want to dig deeper and explore those kind of aspects, it would be quite interesting to learn and see more about it. In fact, no one in the class has done it before, so it's a bit of a interesting exercise. All right, cool. So bringing it back. So that was a bit of a detour, of course, but I think it's still worthwhile to learn about this. So we had foreground services, which are for user-centric activities, so direct interaction with the user or some sort of user I/O, right? So towards the user. Yeah, basically interacting with the user. We had single-threaded services, which are for simple sequential execution. Basically, if you want a service and you don't want to think about it, that's the way to go for, the one to go for, usually. If you want to have the absolute flexibility, so basically kind of it's up to you how you want to process workload, you want to do parallelism or complex interaction patterns, or you just want this code container that you can control to some extent, then just extending the service is the right way to go. And of course, as I showed you just now, basically to some extent, was the if you want to use a client-server model with advanced functionality such as support for IPC and client-server semantics of interaction, then the bound service may be a pathway to go down. So that's the four types that we're actually dealing with mainly. Any questions at this stage? No? Good. Cool. So that's roughly my bit on services so far. Since we are still having a bit of time, and there was the injection that that Async Tasks haven't covered in full depth. I think that was the impression I got just before. I just briefly will talk about those as before. But before doing that, just pointing you to a just a code snippet highlighting the stickiness of the execution, because there was a snippet I put in the wrong slide location here. So basically, I mentioned before, if you're starting a service and you want to indicate whether it should be automatically restarted by the operating system, that's basically how it's done, right? So you have the onStart command, which returns an integer, and the integer is basically a constant that is part of the service class that you can return. So you tell then basically Android how it should treat that particular service, right? Just to bear that in mind. And again, this has those three options of start sticky, redeliver intent, and don't start sticky, right? And if you say redeliver intent, it basically will cache this intent and redeliver it when it restarts that particular service. Okay, right, so resources on the service bit are provided here, services, priorities, IADL, all that kind of stuff. Just a few notes on Async Tasks since we're still here and somewhat alive. So as Marius just said, if you want to do anything asynchronously, and that kind of fits well into the discussion before, well, don't do it on the main thread, right? Why don't we do it on the main thread? Please.
Because then the application says it's not responding and stops.
Yeah. So I mean that's the main thing, right? So first of all, in fact, I mean, independent of the Android semantics, it basically would mean that your application would block, right? So you wouldn't have any feedback because you're basically doing, for example, long-lasting tasks that are downloading stuff or somewhere, and it would prevent interactivity, right? So basically, you would not be able to actually know what's going on in there, not even show the progress of your download anymore, because basically your system is busy with the download in the first place. Android deals with this with those ANR messages, right? So Android not responding messages, which pop up after, what is the current timing? How many seconds are you allowed to block the main thread? I forgot, I need to look it up again. The specs change kind of, I think 5 seconds or something. If you take longer than that with one execution of a function, it shows an ANR. So it's good for testing as well. You need to bear that in mind, that you keep the use the main thread as little as possible, right? Because any execution, of course, consumes time, right? And sometimes it's not predictable how long, or only to some extent predictable. So it's worthwhile when testing to try it on different devices and see how they behave. Those ANR timings are worthwhhile to know. I need to look them up myself, but they are documented in the in the docs. All right. So so we're not allowed to do stuff in the main thread, which is kind of evil. That's of course true. But we have various options for background operations, right? So you're not supposed to necessarily use, well, there's asynchronous tasks. We go to those ones in a second. But bear in mind that asynchronous tasks are tied to their underlying application component. So if you're running an async task, for example, in an activity, the activity dies, the underlying task dies as well, right? So this is precisely a point in time where you can think, okay, why don't you try services, right? So they are kind of a bit decoupled from the activity. So if something runs a bit longer, I can just delegate it to the service and manage that lifetime more independently, or ask the service to shut down once it's done with a particular task, right? So that's the key idea. So you can stop me anytime if you have heard about this before. I just picked it up because Marge said, well, we have only scratched up on this. So basically, Async Task idea builds on Java's threading model, and in contrast to just doing threading, you heard about threading, right? So yeah, so you did thread pools and executors and things like that, right? That you talked about. So those are good for background activities and sensibly to use. The key thing about the Async Task, which makes it really nice to use, is it actually has mechanisms for providing UI feedback, right? So you can actually inquire, hey, Async Task, how far are you in your task execution right now? And that's actually quite neat, because you will not get that from conventional threading because it's just best effort, right? You schedule something and then whatever, good luck. Well, you know when it's finished, but you will not know what the progress is. So you can use async tasks kind of with all application components, right? So if you want to use that in an activity or a service, you can of course do that, but it's probably more sensible to do it in a service because of the long run nature or the unpredictably, especially if you don't know how long it will run. Think about download manager or the like, right? So classical use cases is of course multi-threading. The other one is if you deal with storage or network. So anything I/O heavy, then it's sensible to of course use this mechanism. And to look at the differences, I really like this comparison in a way this schematic overview of the execution in a way. How you deal with async tasks? Well, you create an async task and you specify on pre-execute. Basically, you indicate what the task is supposed, what's supposed to be executed before the async task actually happens. Then you specify what the async task, of course, actually doing. So you provide the necessary parameter, implement your functionality in do in background, and when you inquire from an activity, for example, progress information about the async task, you say publish progress basically, and it will basically invoke on progress update, and it just displays what the progress update is. Think about the the progress bars, stuff like that. So it basically returns a numeric value indicating the extent of progress, and you can then use that, for example, to display it in one way or another, right? Either as a number or visually or so on. And of course, then after execution, there's some result that's going to be processed. So that's roughly the semantics that of how it works. I have a simple example I can just bring up briefly. Yeah, my Gradle just killed itself, so we will not be able to run it, but at least I can show something. So the fundamental idea is you have an activity, right? So it does some stuff. I have to get rid of this. That's not relevant here. And upon click onto a button on the UI, we execute the time waster task. And again, it's a typical a demo exercise of nothingness. And it just say execute something, give it some sort of payload. And here's the implementation of this time waster task, if you like. So it's an extension of the async task, which has indication of the type of input, right? So the type of input, the type of output, and the type of progress. And in this case, I don't implement really the on pre-execute, so I just leave it because I don't want it to display anything. You could, for example, show a toast indicating, okay, now I'm doing something. On progress update, this implementation, what it does basically is directly interacting with the UI, in this case with the progress bar, and setting the progress, right? So it sets the progress based on the progress upgrade information, which is contained in the first, in this particular case, in the first index of the values array here that's passed into the on progress update. And in background, well, it's doing some stuff here, right? So, and what we see here is the doing background is taking integers and doing a thread sleep over parameterized number of iterations, right, as indicated in this array here. And it's regularly publishing the process, basically calculating the process relative to 100%, of course. And this would ensure that the process is published to the UI, basically to the user, right? And finally, once everything is done, it makes a toast and indicates, oh, I'm done, I'm completed, right? So what you see here, it's basically just an extension. If you have seen, if you recall the thread interface structure, what you see here is basically there's a lot of wrapping around the actual core thread functionality, right? So this would correspond to your run method, where you do actually your executional steps. But in this case, it allows you to interact basically with the UI and provides you pre and post execute information on top of that one. So it's quite valuable for this one. And it's fairly straightforward to implement, as you have seen, of course, or yeah, as you see there, I guess. So, of course, async tasks have limitations. Lifetime is attached to a particular application, right? So again, as I mentioned, if the service dies, async task dies. If the activity dies, async task dies, right? But so that's important to bear in mind. They don't necessarily manage own resources. So yeah. So they don't really own resources. They're working on other entities' resources. They don't have any concept of caching, and potentially, depending on the thread pool implementation of your underlying hardware / operating system, meaning version of Android, there may be a limited number of threads that are available because it relies on the OS Android-sponsored thread pool for the execution of tasks. So if you run too many, you may actually see, oh, they're not running, they're actually queuing. And that may be based on constraints because there may only be 128 threads or tasks. But the challenge there is simply you may have other applications running at the same time that use the same functionality, right? So which you can't really predict and know. So bear that in mind. If it's not running, it may just mean that you exceeded the task execution. But generally worthwhile tool. So if you're thinking about using threading in Android, think about async tasks at the same time. Perhaps it makes sense if you want some user interaction. Okay, a lot of talk from my side. Questions? Who thinks I'm talking too fast?
Partially.
Okay, that's good. So I just expected all hands up actually, because that's why I tried out. I'll slow down a bit. It's a bit of a disease of mine, I guess. But any other topical questions related to service or async tasks? Everything clear? It's no magic really. I mean, that's just different concepts that we haven't touched upon yet, but they hook in nicely with what you've known and learned already. And we'll continue a bit like that because I think you guys, I mentioned yesterday already in a lecture that you guys should be well prepared to basically do most of the assignments that you have seen so far, at this stage already. But we can still, show you some specifics, of course, of how to use tools. I understand there will be a lab on how to use SQLite in particular, so that's very extremely helpful. But also other concepts that we talk about. We'll talk about libraries for handling networking, for example, right? So something you can do now already, and I saw some of you doing it already with existing functionality, because you're free to use pretty much any Java library that's out there, right? Which makes it very easy in a way because there's a lot out there. But we'll dive into some specific, functionality that's provided in the Android ecosystem and give you more insights on that one. Cool. If there are no more questions, then yeah, you're free again, right? So you're free to do whatever you like. And we would see you back, I believe, tomorrow. Is that the case? So tomorrow, I think there's a lab on. Sorry?
Room. Yeah, me and Martin were doing a lab on,
Yeah.
On room.
Okay, so there's a lab tomorrow in 8:05, I believe, right? So yeah. So other than that, we'll probably see each other next week on Tuesday again. Good. Thank you very much.